And our r is once again radius of this circle. But if you look at the circle, this is just equals to x squared plus y squared equals to 1. So it means radius is 1. Therefore, we can just integrate it once again between 0 to 1. And finally, our z. Integral of our z will be this thing in terms of r. So you can either write it from negative square root of 1 minus r squared to positive square root of 1 minus r squared. Or the way I like to write it is basically the same thing. I'll just have double integral here. And then third one would be 0 to square root of 1 minus r squared. So this is only top part, and we want to double it because it's symmetrical. So 2 times this whole thing. And this is going to be r because it's determinant of cylindrical coordinates. And then dz, dr, d theta. D theta. And another thing I just want to point out that this basically means somewhere point around here, so it's negative, and when it's positive, it's just going here. So our whole z would be this basically line. Actually, let me do it like that. This whole line. This is our z. So at this point, this is negative 1 minus r squared, and at this point, it's positive 1 minus r squared. And the last thing I want to show you is how to use just general coordinates. For spheres, this might be a little more difficult, but it might be useful in some other cases. So this is going to be integral in terms of x and y. We already solved for z on this circle, right? So z at any point of this circle is going to be that. But now we want to solve for y in terms of x, let's say. So y is going to equals to, on this circle, it's just x squared plus y squared equals to 1. So we solve for y, it's going to be 1 minus x squared, and this whole thing is square rooted. Therefore, you can see that y also goes from negative 1 to 1, because it's unit sphere. So we have integral between negative 1 to 1. X within y goes from negative this to positive. So once again, this is going to be integral between negative square root of 1 minus x squared to positive square root of 1 minus x squared. Once again, we integrate z, and z is going to be once again this between negative and positive. So negative square root, and this just goes in there. I'll just write minus x squared plus minus y squared, and to positive square root, and it's going to be exactly the same thing as here. And this is going to be dz, dx, dy. You can technically substitute these two and calculate basically for x instead of y. And you also have to remember that we need to multiply by determinant. So this is going to be determinant of our transformation. So I'll just call it g. I'm not actually going to solve for determinant, but you can typically figure out any function, and this is how you would actually integrate it in general coordinates and stuff. On a closing note, I just basically want to say that we have basically 3 ways how to actually do that. This is spherical coordinates over here. This is cylindrical, and we just have general coordinates as well. So basically, you can use either way, but instead of figuring out a determinant every single time, it's probably easier to remember determinant for basically for spherical over here, and determinant for cylindrical over here as well. So once you remember those two, you don't need to actually figure out determinants like this. But it is possible, and you should be able to do any out of these ways. Also, I probably will make a video about how to take determinants, and this might help you out with it. Thank you very much for watching. Have a nice day.